Hello, it's Mr. Waz, and I today am going to show you guys how to do the assignment known as Understanding the Power of the Quadrat. So, what is a quadrat? A quadrat is a square, okay, and it can range in size. The one that we have on the picture of the assignment is a very common quadrat that is 1 meter by 1 meter. So it's just a square that's usually made out of PVC. You take 4 PVC pipes that are 1 meter long, and then you take four 90-degree angle PVCs and you connect them all together and you make a square. So what do you do with that? Well, this is the basic tool that is used for the field of science known as ecology. With ecology, you are trying to understand the diversity and the abundance of a population in a particular ecosystem. And guys, this information is really important because it's going to be utilized to propel you into the last question here, which you'll notice has tons of lines. So I want to see all those lines filled up with your wonderful text. So back to the quadrat. A quadrat is used to understand the population of a particular species, or it can be multiple species, and trying to figure out how diverse an ecosystem is and how abundant each of the animals or even plants or substrates that exist there. And so you're trying to mathematically quantify the quality of an ecosystem. That's what ecology is. It's a very difficult thing to do. I mean, think about it. You may notice when you read articles and it says there's only 300 of these right whales left. I mean, does it ever make you think, oh, I guess they counted every single one? Or maybe we know that there is this many, white blood cells left in a body, in a human being. How do we know that there's that many blood cells? Did we count every blood cell? No, we used a quadrat. And so a quadrat is when you drop this quadrat, it could be a meter by meter, and it could be looking at an area that is a mile or even bigger, and you count whatever it is that you're trying to figure out a population within that quadrat, and it creates what's called a subsample. You take that subsample and then you apply it to the total area in which you want to know a population, and boom, bada bing, rather than counting every single thing in that ecosystem, you count a subsample, and it gives you an accurate idea of how many total animals are in that area. We use this with drones when we're trying to figure out how many polar bears are left in the Arctic. And we also use it in coral reefs. So we might be trying to figure out coral coverage and how many corals have bleached in an area, or we might be trying to figure out the total amount of a particular reef fish species. So, for today's activity, we are going to focus on a particular species known as the anthias. The anthias is a small fish. They're usually orange and pinkish color, and they love to hang out in acroporas and elkhorn, which are two types of corals that are usually hanging out on the top of a reef. So they're very small, and they are by the millions in a coral reef. So how the heck are we going to count all of the anthias in a particular reef? Well, that's where the quadrat would come in. So scuba divers will take a quadrat, they'll bring it to a particular area, and they'll stare at that area and count every single little fish in that area for an amount of time. They'll then go to a couple other areas, collecting subsamples. Then they can get an understanding of where the anthias typically hang out, and they can focus in on the coral reef patches in a reef, and then they can figure out from there the total population. Now, what would be absolutely lovely is if I could take you guys all on a trip right now, and we could just go to Australia and count all the anthias and use some quadrats and do that. Unfortunately, I can't do that. So with today's lab, you're going to need some materials. Do not go forward with this video until you have all of the following materials. You're going to need a newspaper. You're going to need a ruler. A ruler is really important. If you don't have a ruler in your house, you could use a tape measure. If you don't have a tape measure, you could probably print one out on a computer. Do what you can to get a ruler, because you're going to need the metric system, because the metric system's just better. If you have to use inches, but we really want you to use the metric system here. You're going to need a pair of scissors. You're going to need a calculator. I'm going to use my phone as my calculator. You're going to need a pencil, because that's just going to help you out. And then what you're going to need is something particularly odd that you're probably going to have to make. You're going to have to make yourself a quadrat. So a quadrat, my quadrat, I just made with paper, and I cut out the middle. And it's funny, I just told you guys to do the metric system. My quadrat is done with inches. I'm kind of embarrassed, I just realized right now. But whatever. If you do the metric system, you would want to do something like 5 centimeters by 5 centimeters. Mine is 2. The inside of the quadrat is what matters the most. How thick the quadrat is, it doesn't really matter, but it's the inside that you're going to focus on this activity. Mine is 2 inches by 2 inches. You could do it 5 centimeters by 5 centimeters. It doesn't really matter. It doesn't like change the numbers, but whatever it is, it needs to be like a perfect square. You don't want it to be like 2 by 3 inches or anything like that. You really want it to be a nice quadrat. So gather those materials before moving forward with this video, please. Another thing that you're going to want to get, if you have your phone, and I would download an app that would make this activity. I just downloaded it. It's called Tally Counter. Again, it's called Tally Counter. And this is going to be really helpful because you can tap it and it's going to keep tally as we're going to go forward with something. It'll make sense. But if you have the ability to download apps onto a phone, I highly recommend you also, in gathering the materials, you download this app called Tally Counter. It's going to make your life a whole lot easier, and you'll see why in just a bit. Okay, so well, you can see what I'm doing here. I got my dock camera going. Here's how this is going to work. I can't go get you those lovely fish known as the anthias. So in this activity, the letter E, which I see E right here, is going to represent the anthias. So every time you see a lowercase e on a newspaper, that's going to represent an anthias. So the objective here with this activity is to see if the quadrat actually will give you an accurate depiction of how many anthias are in this coral reef that we're trying to figure out. So what is the coral reef? In this situation, the coral reef is going to be all the words on this page that are on the article. Now, when you're doing this, you're going to have to choose some articles from a newspaper. Now, the one that I have here is actually too small. You're going to want something that's going to supply you anywhere from 600 to 1,000 E's. That's right. In a little bit, you're going to have to count something like 600 to 1,000 E's. So that's why when I said you want that tally counter, that this is going to be pretty helpful. So you might need to include multiple articles for this, and you could take a pair of scissors and then you could cut out where the articles are. Now, one important thing that you're doing with this activity is that all the text that you use must be the same size font. That's really important. So I don't really care about the titles of these articles. I don't care about the advertisements or the side boxes that are under images. I'm not even going to care about this because this is italics and it's a different like font. I just want classic newspaper font size text to use for my coral reef. So if this won't produce me 600 E's, so I'm just going to have to hunt in multiple articles in my Plainville Citizen newspaper. Like I can go and grab this too, and I'll cut this out, and I'm going to create myself a nice substantial coral reef. So that's what I would be doing, but I'm not going to do that right now because I'm showing you how this is going to work. So the first thing you have to do with this activity is you have to count every single anthias, every single lowercase e on all of your articles. I do things like this. I cross off this stuff because I know I'm not going to be using that. And you're going to start from the top and you're going to go through. And hopefully I got the camera at the right angle here. And this is probably the easiest. With my left hand, I got my finger on the tally. With my right hand, I am just counting those E's. And I am going one by one across here, looking for those E's, line by line. This is going to take a while, and you're going to want to take your time. And if you're going to feel like you need to take a break, go ahead and take a break. Just make sure that you still got your number and that you don't lose it. You don't want to keep this in your head. That's going to cause some serious stress on you. Just doing this right now, I'm seeing when I do it at the same time, like when I click down and cross it at the same time, that is helping my brain do this very effectively without being confused. So that's what you're going to want to do here. And you want to get, again, at least 600, guys, because if you do anything less than that, you're not looking at an efficient coral reef system for your anthias. Your sample is going to be too small, and you're just not really being a good ecologist. So that is step one. You're then going to write the amount of time it took you, which should be a while. And then you're going to, right here, you're going to write the amount of E's. So then you have to calculate the area that you used. And this is going to take you some time. Okay, so taking your ruler, you are going to have to measure the text boxes. So you don't just do this whole newspaper, because I want you to think of this area right here. This is blank ocean space. So this is an area that an anthias would never swim near. They're going to stay in their patches of reef. So if you're a good marine ecologist, you know when you need to find your total area that you need to just focus on the patches of reef, which is where you'd see the letter E, or anthias. So when you calculate your area, you want to just focus on the text boxes. Now, you can leave that part in. So like most of my text boxes I can see are going to be at the most 40 centimeters. And then I'm going to measure its height. Mine is, oh shoot, well, not 40 centimeters, 4. My ruler's in millimeters, so I need to remind myself that. So I'm at 18.5 centimeters by 4. So then what you're going to do is, on a piece of paper, you're going to keep track of all of your areas. So this first one I have here is 18 by 4, and then my next one is still 4. They're all going to be 4 because you can tell that these are the same. This next one is a 9 by 4, and this one's pretty much the same because they're equal, so I have another 9 by 4. So on a piece of paper, you're just going to write down all the areas of all your text boxes. Now, I only have 3 in my example here, but you're going to have more. You're probably going to have like 15 or 16 or something, or 15 to 20, something like that likely. And then so you're going to figure out all the areas, which you just do length times width equals length times width equals length times width. And then you're going to find their total. And by finding the total, you simply just add all the text boxes together, all the areas together, and then you're going to write that area here. This is so number 1 and 2 on this take you the longest. It's setting up the coral reef situation. Okay, so now you're ready to really use the quadrat. Now you know how many E's there are. So let's see if you capture a couple subsamples if this thing actually works. So what people do with their quadrat is they drop it randomly in a spot. Now, it doesn't need to be straight. It can be dropped like this. You just don't want it to be hanging out in the middle of the ocean. You want it to actually be where a reef is. So let's say I do this spot right here. So what I'm then doing is, just to make my life easy, I'm penciling the area. You could even use a pen if you are having trouble seeing. Well, of course this pen is like almost, it's orange of all colors. Come on. So now what I'm going to then do is I'm going to count all the E's that are inside of my quadrat. So so I would go and count the E's. Now, just looking at this now, my quadrats that are at school that I wish I could get are smaller. And I know I said before do like a 5 by 5, but honestly, if you did like a 3 by 3 centimeter quadrat, that would also be good. This quadrat seems, looking at it now, it seems to be a little on the big side. So if you did like a 3 by 3, I think that might help make this part a little bit easier. But anyway, whatever. If you did 5, it's fine. So you go ahead and you count all the E's, and you are going to mark your E's in, you're going to write your E's right here. Now, on my assignment, and this might be updated by the time you guys see this, it says only do this once. I want you to do this 3 times, and I want you to take all 3 trials, and then I want you to find the average. So I'm probably going to change this assignment. I'm just noticing it now for this video, but I'm probably going to update this assignment, and you're going to have to do 3 drops of your quadrat in 3 different spots. You're then going to find the amount of E's in the 3 spots and then average them, because that's what a marine ecologist does. And last, you just need to tell me how much time it took. And what I want you to see there is obviously when you did it this way with the quadrat, it took you a significant less amount of time. Okay, so now what you have to do is you have to see how accurate your quadrat was to the true numbers. So there are 4 numbers that you need in order to do this. You need that total area of all the newspaper pieces that you took. I'm going to say that my total area is 1,080. Now, all your numbers are going to be different for these. These are just example numbers here. My total number of E's that I spent time counting, I came to 620. So when I did 3 trials of dropping my average, I seem to have finished around 17 E's in 3 drops after I divided it by 3. And then my area of the inside of my quadrat that I kept getting 17 E's in is 25 centimeters squared. So now what I have to do is I have to figure out how many quadrats exist inside of my total area. So I'm going to do 1,080 divided by 25. And so what I find out is that there are basically 43.2 quadrats in my coral reef. So if I had to cover every single spot on my coral reef with a quadrat, I would need to do 43 quadrats, like quadrat drops. but I only did 3, so I obviously saved a whole lot of time. So now I know that the total amount of E's is 620. I know that on average when I'm dropping, I get 17. And I know that there's 43 quadrats. So what do you then do? You say, okay, well, if I drop that quadrat 43.2 times and I kept getting the number 17, what do I get? So 43.2 times 17, I get 734. So when I just did the quadrat, I get a higher number than when I actually counted all those antheus. So I did not do a really great job. I didn't get the same number, did I? You might do a much better job than I did. So how bad did I do? Okay, so to do that, I need to take my quadrat number, which is 734, minus 620, just to see how many antheus I was off by. So I feel like that Khan Academy guy right now. I think honestly I even sound like him. I'm not even meaning to, but I've watched a bunch of those, and I think because I'm teaching math right now, I'm just getting the Khan Academy dude voice. I apologize. That's not a normal WAS. So anyway, I was off by 114.4 antheus. So how bad is that? I would then take 114.4 and divide it by the true number, which is 620. I then got to times it by 100 for percentage, and I find that I did bad. I got an 18.4% error. So that's how you do the last part of this assignment. Now, what I'm going to tell you is, if you're getting anything above 15, I want you to go back and do some more trials with your letter E, or figure out what's going on. You probably have a mathematical error if you have less than 15. I will tell you this, guys. I have had, in my 6 years doing this assignment, I have had multiple kids be off by like 1 E, or even I had one kid, Zach Katz, he got the exact same amount of E's. His mind was blown. And that's the whole purpose of this assignment, is that if you do this assignment correctly, you will see that the Quadrat is quite a powerful tool. So, to conclude, a quadrat is our main tool. It's such a simple thing, right? When you think about it, it's a square. It's a square. But it allows us to understand the diversity and the abundance of marine creatures that exist in our ocean, because we really just simply can't count every single one. And we use this on the land as well. We use this when we're trying to figure out things about our body. I used quadrats when I worked in a fish biology lab. I would take the ovaries of fish and I would put them under a microscope and count little teeny tiny eggs in a quadrat that was a half a centimeter by a half a centimeter, and then I would multiply that by the actual size of the fish's ovaries to understand how many eggs were in a sack of ovaries. And then we would look at the size of the fish, and we were able to mathematically figure out, by just looking at the size of a fish, how many babies that they produce. So scientists use quadrats all the time, and they work. If you're good in your math and you're accurate with your measuring, it works and it's effective. You can use it when figuring out stuff inside your body, counting polar bears in the Arctic, counting antheus in a coral reef, trying to figure out how many invasive lionfish are still existing in the Caribbean, or invasive crown-nosed starfish in Australia. You could use it to figure out coral reef bleaching coverage in case, it was too hot like it was this year. and you want to see how many corals survived and how many corals did not, you guys actually did it on the Hammonasset trip. So if you don't believe me and you feel like you need more things to write, simply Google search "how does a quadrat work in ecology," and you're going to get a lot of interesting articles and people that have used quadrat effectively. All right, everybody, that's all I got for you today for this lesson. I hope that this helped you understand the power of the quadrat.